So I'm kind of like, what the heck?
Did I just
Oh, I work with
really didn't work.
Or really didn't work.
Well, it did, but like it wasn't
I
really
don't know.
like
I
copy
might
paste
have
and
used
edited
it
stuff, you just copy and paste
I'm not
that
sure.
stuff. So I submitted that and I'm like.
But still, it says use prescription. I'm gonna do.
Yeah.
For field camp. Here we go.
Yeah. Yeah.
People, my people. It smells like December, and December 1st is my birthday, so I'm gonna turn 28.
In the final paper.
In my dreams. Yeah.
I haven't looked at it. Yeah, you include everybody's not. Just contact everyone, get a picture records and that fucking document. Yeah. I took notes during the presentation.
Yeah. We have coordination.
I did not take notes on my own methods. They tell me no.
So,
I can ask Celeste.
yeah.
Like I didn't ask, sorry, yeah, notes. I like, I didn't hear take notes, I'm like, there's data analysis.
Too close.
Okay, back to my social group right here, Michaela. Calm them down, please. Okay, so the question in the back was if you're gonna get your lab comments and marks, right?
Yeah, because we're still waiting for those.
Yeah. So the answer is I'll send an email to my group, Caroline's group, Kunali, and Natalie. Yeah, and Caroline, to see where we are with that. I'm sure they're fully aware. Oh, excuse me, guys. Excuse me, guys, just like they can't hear the back if I say something. So, yeah, they're fully aware that your second report is due, therefore they want you to see the comments on your first one. Yeah, absolutely, they're fully aware of that. So I hope it's gonna work. I hope it's gonna work. It changes the whole process. We're just trying to be fair. The idea is to have two reports is to build on the first one. So if you don't have the first one, you can't build on it. So it's a bit of a waste to repeat errors all the time, or, you know, if there's any. Right, so yeah, we have to do that. Yes. All right. Warm up and introduction. We're getting near the end. I feel the end coming soon. I know last day of classes is probably on a Monday. That's right. I think it's on Monday the 6th or something like that. So we got at least the next week. So today, and, in my dream, I was finishing the course today, but in reality, we might extend until next class. So in other words, the material is going to be a little short. The idea is that I hope it's condensed enough that you have material. It's not a 40 course. Plenty of new vocabulary that applies strictly. So open a new drawer in your memory bank, your hard drive, pull out the wildlife management jargon, and you're talking only wildlife management for the exam. So that's the idea. Now, that being said, a fourth year course is somewhat different from a second year class because you don't have to question whether the students are intelligent. If you're at fourth year, you made it through. So we're not there to test really the ability to read questions and stuff like that. But half of my workload to me is keeping you interested in the material. That means that I want you to pull out with positive memories of wildlife management and the concepts we've talked about and the breadth of the discipline. And that's the best way to get the job at the interview is to show excitement over wildlife management, if that's the requirement. So keep in mind, of course, that we're primarily ecologists. As I said many times, all kinds of different people around the table to discuss management. And of course, we're rehashing somewhat the same material over and over again. So the global issue is always very simple. There's an interface between wildlife and man. What kind of a relationship, a positive, neutral, or negative? What solution can we bring? If there's no problem, there's no management necessary. If we could live in this room with 10 black bears, we would, but we can't. It's a bit dangerous, just to let you know. All right, so nitty gritty, chapter 6, I was hoping to get chapter 9. I'm building this course, as you know, so bear with me. I hope I've covered most of the important elements. If you're going into another university, tell me some aspects of wildlife management. You got 7 chapters. So we start very slowly with the breadth of wildlife. What is management? And now we're into specific aspect of wildlife management, which could be your next job. Is it you could be hired as a habitat specialist. Suddenly, the fish person comes to you. You're the one doing the sampling for habitat strictly. See where we're going with this? So we start with wildlife and then management, and then suddenly it's all habitat because it seems to be a recurrent theme. So at the final exam, guaranteed, we'll talk about habitat management. All right. So the moose, I don't touch. I don't touch the deer. I touch only the spruce and the ferns, whatever is required. All right. Now, habitat in itself is not simple because habitat is supposed to mean that it offers resources to wildlife species. Because the resources are not the same from one species to the next. Therefore, habitat is multitude. We're looking just at one dimension of habitat, which is well, we could talk about composition. We're going to bring Dr. Reiser here. Talk about diversity of plants and why is it important to have 12 species of ferns to maintain plant squirrels, stuff like that. So that's composition. In this, the minute we talk about landscape, we're talking in your mind, think of it, approach it as geography. And that's too bad. That's really spent 3 credits geography course on the same topic. The idea is that we're not looking at configuration to build a condo. We're looking at configuration, composition. In other words, what I call landscape patterns, correct? For a purpose which is wildlife. Therefore, it's an applied section of landscape metrics. Landscape ecology is subdivision. So it got complicated because, of course, we're talking habitat loss. You know the story. We've gone through a few of those slides already. I just want to rehash it quickly. The literature, according to Farig and many other authors, she put her foot down and she said, I'm going to write this paper. I'm going to collect 100 papers and see who says what, who says loss, who says fragmentation, and how does it turn out in the paper? What's the response of the wildlife? So she classified the papers, and that's called a meta-analysis. And she ended up with something like that, as you remember. It's revealing for 2 aspects. I said that already. So first of all, there's a list. I call it empirical. It's a list she built as she was going through the papers. Oh man, another item. So on the column, you have the fragmentation or predictor variable. There are several, and I like it. I mean, if you really dug into if you go only mainstream read 5 papers, you're going to say, well, everybody measures abundance and patch size. So the chances are that paper is on patch size and abundance. Okay. So first of all, very revealing for the diversity of the predictor variables. So different aspects, if you will, different features. In another word, you might say the exam, different features of a landscape. Patch size, habitat loss amount, patch isolation, edge, number of patches, structural productivity, as opposed to genetic connectivity, matrix, patch shape, and so on. And then on the horizontal, as you know, different measures. So top left is the easiest because the most common. Abundance is the first thing you want to measure, and then patch size is you're already in it. So you see who's dropping, so where am I? So you're in a patch, measure patch size. All right. So that's pretty easy, and that means it's low budget. And this paper and the textbook I was referring to, Porter et al., they both advocate for going bigger. That's your job, not my job. It's going to be your job at your next. Yeah. As a habitat called it, to go big right away. So you work for a district, a county, a township, a subdivision of some sort. I call them jurisdiction. If you recall, jurisdiction, general term for all these levels. And say, I don't know, District of Arizona, who's a volunteer. I sure hope at the interview you say, you know what, we're going to talk to North Bay, find out what's happening with the deer in North Bay because it's next door. Right away, you're jumping landscape. So you're setting your patch size, your patch, your habitat, and looking at the surroundings, the landscape. Right. So definitely much harder to measure, and this is why these scales come last in the series of predictor variables. We've seen this already. Process of habitat fragmentation. I insist, key trick question for the exam. What am I looking at? I removed the legend, correct, on the questionnaire. So just the picture. So then you gotta self-test yourself. You hide the legend and try to figure out what I gotta say on this. It'll be a very short question. What am I looking at? I'm looking at the habitat loss and fragmentation. The title, the legend, is misleading. You know how to measure habitat amount, correct? That's pretty easy. So out of kilometer, for example, if this square is a kilometer, left one is 100% habitat, correct? I can see the second one is maybe somewhere around half or something, and then so definitely you habitat loss, correct? So the black is reducing its area, if that's your habitat, and that's what it says in the legend. But there's also some kind of a fragmentation here because I get more patches. So this becomes key right here. So that was some kind of a preamble just to warm up the audience, but this is key right here is habitat loss versus habitat fragmentation, which is at the bottom. Second point here is expected effects. Is effects of fragmentation. I should be clear on that slide. All right. So when I see an increased number of patches, if I divide something, so let's say I have a full block, I could use this example. I got one patch right here, continuous, and I just created two patches, so I fragmented same area, right? Very simple, very straightforward. It's just that when you read the next paper and they talk about loss and fragmentation, just go, whoa, a second. Is it really habitat loss? And sure enough, it's almost guaranteed to be habitat loss. So I think 90% papers are right when they say, oh, we're losing sharks to habitat loss, we're losing koalas to habitat loss. Indeed, most scientists know that loss is area coverage for a given forest, a given pond, whatever. So habitat loss is a major driver. You will not leave this course without that for sure, right? So it is still a cause, it's still a challenge, still, and the thing is, we're infringing on every possible Michaela says she wants to fly to Mars. Did you say that last week? Oh, my mind, eh? And tricks. So increased number of patches, fragmentation. So let's see what kind of fragmentation do we have right here. So I'm going to go from, I'm picking one of those, and I hope one of them is showing me fragmentation without the loss. You see what I did right here? So I got this patch right here and I fragmented. Sorry. It's very rare that we do that as humans. Actually, we take the table off. We needed that space for cropland. We needed that space for the wood that was on it. We destroy, we remove habitat as humans. That's why it's a question for the exam. Why is between loss and fragmentation? Why is loss the major factor? Is because this is what we do the most. We infringe on wildlife habitat. And unfortunately, it's somewhat mathematical. We're just a bunch of primates on this planet. So more and more infringing on, name it, Amazon forest, desert, bring irrigation, the forest behind it, desertification. So we're habitat loss is the major factor. Regardless, fragmentation itself will create a number of patches, such as this one. I was going to point to the say ×0 right here, and some effect that I created, and I'm not comparing, of course, the patches right here, and obviously I have the same areas because even the smaller ones, they pointer, another pointer. We'll see if it's a good day. Oh, what a good day that is. So I count the blocks. I got the same number of blocks. No, sorry. Number of patches will increase. I'm looking at this model right here where the two small ones are still there, right? So obviously I haven't removed anything. I haven't removed the forest or removed the crop, but I subdivided. I just opened up a little area. That's a concern. That's fragmentation right there. So area fragmentation is called fragmentation per se. That means strictly fragmentation is pretty unusual, but this is what it definitely looks like. So increased number of patches, such as this one, you recognize I got more patches, correct? The mean patch size will decrease because this one is now smaller, so average or mean patch size is smaller. And I should have an increase in patch isolation. This is also core for the final exam. Again, every paper that the authority will rewrite will be application of these principles she put out in that paper. So if I wanted to summarize this, like question of the exam, summarize this figure, what am I looking at? I'm definitely looking at the relationship between the effect of some sort, a measure of fragmentation, and the habitat. Again, the exam, it'd be nice to realize that this is good only. It's mostly useful for when you're thinking habitat loss, so it has to be read backwards. So you have to look at the pristine condition, which is 100% habitat, and what happens when you fragment the habitat. So if you reduce the amount of habitat, your number of patches will go from very low because you have one patch. I could go back, of course, if you have 100%, looks like this to the right, to the left. So definitely, I have a bell curve, two bell curves. I see two positive relationships and I see one negative relationship. That's not a bad way to summarize this figure. And separately, you could list the y-axis. I'm looking at number of patches, bell curve. I'm looking at total edges, bell curve as well. You all know how to read a bell curve, so you look at the extremes and the middle, so the mode, if you like, right here, so which is about middle. This is based nothing on probably data set somewhere, but it's not showing. So number of patches, bell curve, total edge is bell curve as well. So in other words, if you want more edge, you reduce your habitat to 50%. Everybody sees that. So it's true for these two. You will increase your number of patches from very few, like one, I suppose. And you take half out and you increase the number of patches. Maximum. Of course, right here, you all understand that if I'm suddenly clear cutting everything, I'm about that habitat amount 1%. I can't have the serious number of patches. So this is the response of these two spatial configurations to habitat loss. This one, the patch size will diminish as you decrease the amount. So think of koala forest, and you remove some. Obviously, the patch size will decrease. This is an average patch size. Regardless how you cut in there, if you remove, creating a negative effect on average. I'm going to say average patch size. And then this one definitely has a positive effect. As you remove habitat loss, what you're looking at is the distance. Well, that's called isolation, what you're seeing here. That's the only positive effect. As you remove habitat, you increase isolation if isolation was desirable. It never is, right? We understand connectivity is actually what we need. So nothing too interesting, but notice that I have 5 graphs, so actually that the minimum at the exam I can ask the list of five predictor variables analyzed. So it's quite redundant with something like this, for example. So we don't have to look at them all. So this is a figure 4 advocates for a landscape approach, where you could have the wrong idea looking at a patch scale study. You got 3 patches, and the tendency seems to be decreasing. Whereas if you look at the landscape, these 3, notice that this one is the same as this one. If you look at the surrounding and they're positive, suddenly you have a positive relationship on the abundance, mean abundance. Same calculation, larger scale. So it's sort of a word of caution. Again, we could have a good pocket somewhere totally isolated. Boring by now. I think I finished last course by saying that the only way to fragment without habitat loss, because I keep saying we cut into the forest, we build roads, we keep removing material. So it's pretty rare that we just strictly fragment. And then yesterday, listening to some talks, I got excited over the whole topic of road ecology. The road doesn't look like much habitat removal. That's my topic here. Yes, it's there. All right. So, so habitat fragmentation, not so much, because most commonly we take some of the habitat away, therefore we create habitat loss. So I finished by saying the only way to have fragmentation alone, compensate for whatever I could want. So in this example right here, if I go at this, I'm going to pick this path right here. Path. And this is the fragment only. What about it that I want to break it in pieces, but it's from over sides? It's very difficult to move the pieces apart, so therefore I will almost invariably remove some of the material. So I That's almost a given. I'm near 100% thinking every time we approach a habitat, we modify the spatial configuration because we remove some of it. So now we're very high probability that we're doing some damage by habitat loss right here. Very common. Habitat fragmentation is when you, and that's what I said last time, is when you break in pieces by removing like this case right here. I removed some of this right here in order to create two smaller patches. So there was loss. The only way to have fragmentation alone, good answer the final exam, is to compensate for what we lost and recreate or create new habitat. So basically, you're saying to the forester, yeah, you can clear cut. Just make sure there's just as much when you left. That's what reading is all about. That's what planting plantations are all about, pretty much, right? Although there's a bit of that, of course, all kinds of debates around that. All right, so to me, that's a sort of a important lesson for management is thinking habitat. How do I preserve habitat? How do I let other humans, other users, I'm going to say, in the forest, cut a ATV trail, clear cutting, selective cutting, do all what they do in the forest, for example, and yet maintain habitat is by creating new habitat because there will be loss. This figure right here, 7 is very straightforward. This is just a practical application of isolation, where the context, where any given point like this, for example, N is less isolated right here, and I stands for isolated. Nothing too revealing about that. But you realize this is all part of the connectivity. Obviously, this one isolation can create problems. We all know that. Here's something that I hadn't talked about. This is also related to habitat. It's called the habitat threshold hypothesis. And please bring that expression to decant. Called the threshold. The habitat threshold hypothesis. Threshold is a pretty simple idea that there's a minimum height. It's not one spruce for one moose. It's not, you need a minimum before you even get started. So one spruce, I don't have a moose. 10 spruce, do I have a moose? Do I yet have a moose? 1,000 spruce, do I get moose? All right, so that's the idea that there's a limit. That's your threshold. There's a limit below which habitat will not support a population. I hope I said population. One individual doesn't count. It might be transient, might be sterile, doesn't count. So we're talking population before you even talk that. So we need some kind of measure of abundance. So at some point, you cut, and you say, oh, Jerry, 20% of the forest. Well, what is the threshold at 25? Right? So this is true for general cover, but for birds, for example, you have to measure densities of forestry debris, densities per unit area in order to find exactly that. How much forestry debris do I need? Or I think about getting some, for example, woodpecker. All right, very simple. So you got your definition for this. The threshold hypothesis suggests that the relationship with habitat is not proportional. That at a very low number, below a certain threshold value for a given species, correct? The model will vary somewhat per species. There will be no population possible. So at this point right here, I have, let's say, for example, in this scale, maybe 40% habitat, yet 0 population. pretty useful, but it brings a bit of modesty and of course for conservation and pure health, we need, 1,000 square kilometers. Why do you need 1,000 square kilometers? Animals need only a square kilometer. Well, there's a threshold of population, so you need the population there. The take home from Farig, 2003 habitat loss is a major factor. We said that already. Habitat fragmentation can have negative but also positive effects. So breaking down in itself, that's why it becomes important to make the distinction. If in your mind you're thinking fragmentation is loss, you're screwed. Fragmentation is the breaking up into pieces. So if fragmentation alone occurs, it can have positive effects. For a given amount of habitat, say 40%, I'm allowed breaking in pieces just like I would break a block of ice. No loss whatsoever, just fracture, correct? So again, if I need to remove stuff in order to fragment it, but I plant somewhere else, I'm talking forest all the time. Therefore, I have created fragmentation with a constant habitat amount. So in itself, the fragmentation can have positive effects. So here, of course, I talked about species using edges, obviously. So that gets very tricky. I don't know how far we are into it, except for the prized game species such as the moose. Everything we know, we want to know about moose is known. For the veg. But it has a positive effect. So keeping it is one way for a forester to that's the excuse for going in. And not through cutting, but cutting. So logging has a positive effect on veg species. We named quite a few of those, I think. And that makes a big difference between habitat loss and fragmentation. So, of course, her final points about semantics, making sure that both terms are used at the proper time. So, if you say fragmentation, you really mean it. That's what she's saying. I added this separate paper. I'm building this course as we go. And sure. And Dion is a ministry agent from raise your hands. People who know South Porcupine. Anybody from South Porcupine around? No. That's a nice place to go. Leave the big town of Timmins, go south. Nice motel. That's all there is, but it's a nice motel. All right. So Dion, Rob Dion, person I work with, eventually published later on. It's already open on forest fragmentation, forest management. And it's a plea, it's published by a Forestry Chronicle, just for your information. It's not journals like this one. Started charging for their papers. So if you're rich, you publish in Forestry Chronicle. We can, and the Forestry Chronicle would be the only one where you would be charged. So this is where you put your politics. So this is a ministry agent who is a habitat specialist. For empirical data. So that's your next job. Very useful. Very few people. For myself, for example, myself, if I mean, I've created as much as I could throughout my my work years, create an interface with the community of some sort. So of course related to ecology. So a couple of times on radio for general ecology of black bears, stuff like that. Also attended some wildlife, some trapper meetings. But it's never like the ministry agent spends their day on the phone with these people. So they really talk the same language, and that you have to build some kind of a trust with these people. So at some point, they prefer to talk to Rob when it comes to habitat and stuff like that. So ministry agent, pretty important job. That's why he's right in between, says the ministry can't provide enough data. Researchers give us some databases so that we can provide the managers. Tembec or other logging companies on habitat configuration. So this paper is a bit separate, just on a different paper, same topic. This is what I consider, I'd like to think of it as the last chapter of this course. I still have time on my talk about selection, so bear with me. This one is pretty short. It's funny, I heard of courses that have 180 slides per PowerPoint file. I'm getting there, I promise. I'll get there. I didn't know what title to give it, and sure enough, picking a textbook is not the easiest thing. I have to order it all and read them for 6 months. But so far that I've seen out of maybe 10 that I looked, none of them really is undergrad textbook. So they're really for managers who want to read topic. So that is true for this one. I didn't know it beforehand. The authors are absolutely knowledgeable, so there's no question that the material is valid. The approach overall, so there's usually an idea behind the book. And in this one, it's pretty specialized, more specialized than I expected. That doesn't give a very good perspective. We'll hear about Midwest, the Midwest, and prairies. Because they're each of these authors' personal experiences in the prairie, that's where they work. I picked a few chapters to show you what's important. It's also the next few slides, I think. All these slides are extracted from that monograph. So I started chapter 4. I skipped a few. Some are synthesis and so on. So I mean, at some point it becomes a bit redundant. So I just wanted to get a good first feel of what that textbook. The next one, I'll do exactly the same thing. Flip the pages quickly. Look at the pictures. Pictures summarize usually what's in the text, and then if you get hooked on, you read the material of the chapter. So the name of the authors are not important. Peroto Valdivieso right here. Spatial patterns affect wildlife. Very important. And they talk about related processes. Am I allowed at the exam to ask what they mean by related processes? Anybody? An example of how spatial configuration will change the processes within wildlife. What kind of processes are we talking about? I'm just giving my reading, just share.
Migration.
Migration is absolutely movement, migration, birth, yeah, name it. So wildlife ecology, you're right. And migration, just a daily movement, for example, which are essential, so that's what they're called processes, right? So your coyote, your fox, does have to move. So advances in theoretical work and computer power and satellite images, you can imagine this is nothing new to you guys. I'm going to partake from multi-scale approaches, so your next boss will have to be convinced of that. So it's like this version 2.0, we're moving great strides. Suddenly, every habitat specialist will have to do that. Every conference, say multi-scale approach. We have to get used to this. Thank God we have GIS specialists and we have stats specialists around. So if you know of anyone who's into stats or geography, You make friends at the pub, stay a little longer. Okay, so multi-scale approaches for sure. So decision at small scale, that's why I keep referring to. Subroot makes a decision on black bear. It really depends what's happening next door, right? So the large scale approach, this is just a restatement of the same thing. Decision at small scale will coalesce at larger scales. Think of it also as it could be, I mean, question for the exam, well, what's the problem with using a small scale? I could name a few, but certainly the fact that I would say the work could be useless because you're counteracted by your matrix. So it could be useless. In other words, it's not a permanent solution. And whatever action you're taking could be multiplied or divided by the matrix, what's happening. So in other words, if you're, simple example, I'm reintroducing calc and separate, and Norbit just opened the license and killed. All right. So coalesce meaning the two effects will merge. So habitat versus other patches in the landscape. Not so much matrix, I should say. Other patches in the landscape. I prefer to say that. Maintaining spatial heterogeneity will be key to sustainability. Of course, you can imagine that heterogeneity. I think, yeah, it does say spatial, very important. So we're talking genetic heterogeneity. So for habitat, how do you maintain heterogeneity? I say you go back to the table of Ferry 2003. Look at patch size, edge, nearest distance. That's heterogeneity. You vary those elements, those parameters, those features of the landscape. You are likely to get better biodiversity. And I think it's a nice approach because managing strictly for one species is probably a thing of the past. Weren't we talking about this during an oral at some point? People say, why do you reintroduce some species and so on and justify the business? Another one species, and suddenly you got 20 vulnerable species who are affected by the reintroduction. So a little tricky to think of one species. So spatial heterogeneity again, please take note to link it to some parameters. I could ask you, how do you maintain spatial heterogeneity? Is by changing specific parameters within the landscape. Outside. And edge and distance to nearest neighbor. Here's a drop of modesty. I could have asked, okay, we talked about patch size, okay, scale. What is a good patch size? Answer the question mark. So we just don't know. For many species, we just don't know. So it's all about habitat. Very focal habitat suitability models that will dictate the area or the habitat amount within a patch. I'm going to say your population cannot survive if you don't have in the landscape. In the landscape, very patch size. One patch size will not give you population. This does not mean patches that through. And right here it says if you want to take a chance on that and you want to say regreen in some pattern, how about create several patches, several patch sizes, heterogeneity, several distances. We didn't go into any kind of mathematical equation to estimate the edge to center and there's all kinds of other parameters that are pretty useful. But I think intuitively, you know, that a circle has less edge than a oval. Correct? Right? You remember that from high school somewhere? So your circle will have the least edge compared to an oval, for example, or a rectangle, square versus rectangle. All right, so the edge becomes pretty important. So the scales have to be studied per species for sure. And we'll get to that at some point. We always find some solutions to keep our jobs, so. Said, tell your boss, I don't know the scale, I'll find you a little twist to it. Wildlife ecology and landscape ecology. So those are to be bridged. Wildlife ecology, we know quite well. Thing is, how does it translate to a proper landscape? That's a new one. That's a bit newer stuff. We know this already, so that's the fragmentation. Just wanted to show you that they repeat themselves over and over again, looking at forest versus pasture. Forest is in pale right here, so I got this amount of forest, and I don't know what species they're looking at. If it's sheep, I'd be looking at pasture. But nevertheless, both of them become fragmented. So this pattern right here is pretty tricky. Obviously, you can appreciate the amount of edge that I have suddenly. If I'm looking at a pasture, every pasture has got a coyote just waiting for the sheep inside. So not a pretty sight. So if you're a farmer and your farmland looks like that, not in luck, not at all. There's an opposite situation that happens north of, I'm gonna guess Alberta or Manitoba. It's a wooded area. And, they have that caribou, I think so. They have a large herd. And suddenly they realize that the herd is in trouble, and they found out that the wolf is doing really well, and they found out why. It's because for some geological survey lines had to be cut down just for access. So if you look at Google Earth, you'll see Alberta's got a grid over it, and it's all open habitat. So your wolf is just traveling crazy, and your caribou is trying to hide in what's left. So it looks a bit like this right now. It's pretty crazy, and just the amount, the fact that I just mentioned that it's a geological, you're thinking if they make a grid, you're talking a lot of those access points for the animals. So similar habitat amount, but fragmentation. A little tricky. I just gave you an example of an animal prefers, what's the opposite of the edge? What did I say again? You're in the forest and you got the edge, yeah. Yeah, center is good, or center. And by that, I depends on the species, by definitely point to an area that doesn't have the edge, where you will penetrate, for example, or something. So that's called a forest center. The animals I work with, the marten, the females in March, when they just mated, they snap at the male, don't want to see you ever again, and then they run until they don't hear a chainsaw, an ATV, nothing at all. That's to a marten, that's a forest core, forest center where the edge is not felt. I'm going to stop in a few minutes. More acronyms. I hope you're on the side there when you know, before or after the shower. Build yourself a never-ending list of acronyms. Here's another one. So wildlife management area, very common in literature. This one is in Mason Mountain. That's an abbreviation when the prof is lazy. It's in Texas. They do have a mountain somewhere in Texas. Don't want to go. I summarize right here what's in the very long legend for no reason. The textbook just lost a few points. So in A, I call them A and B on top here. They didn't bother, they should have. Was like a forest, shrubland, and grassland patches. So in other words, one picture that's showing the vegetation cover. And this one adds a soil topography and management for the same area. So definitely it has to do with sensitivity of your detection methods. Satellite imagery is one of them. Could also be GIS layers. Here's another picture. We're still with beach, chapter 5 of that same textbook. Talking about the prairies, yeah, they do spend a lot of time there. And sure enough, if I were to work in the landscape about that, I think I'd prefer to work there. Simpler than so it's flat and they got prairies. And burns is part of it, you know that already, right? The fire ecology, we've talked a bit for a habitat, I hope. Natural process, periodic process, cyclic process, and that's what they deal with in the prairies. They don't want huge fires. They don't want to expel people from the villages, so they control the, what is the expression I'm looking for here? Let's be practical and wildlife management. You're managing fire. What is it that you're controlling? The word with 4 letters. What do firefighters call it? No, just a 4-letter word I'm looking for. What is a firefighter trying to reduce? The fire, no? Yeah. That question, Victoria, an example of a bad question. Okay, it's still a 4-letter word. It starts with an F, yeah. Fuel, thank you. So fuel wood is definitely a term where it combines everything from what's out there, for some forests are drier than others. What's out there, and also, whether it's wet or not. So bottom line is, they call it fuel. Obviously, you don't want it because it fuels the fire. And the prairies do that all the time. That's how they maintain the prairies. It's a natural process, but it's hard on the villages. So they prevent it by prescribed burns or controlled burns, correct? They're both the same. That means, of course, they can fire it up and they can turn it off if they wish and have it where they want. There's 2 patterns showing, and a bad textbook like this one will not make a huge contrast between the 2, but here's my take on it. So I have burn on one side, on bird on the other. I'm looking at the left one here. Obviously, they burn in a line, or a line of fire. And the arrows, good for the exam, the arrows are showing propagation. So whatever you want to call it. It's called propagule. That's the term right there. So the first one's the line of fire, and they look at the regreening. So they're interested in knowing what happens in 1 or 2 scenarios. This one is a bit different. You can see the arrows being different. Obviously, dispersal, I should say. Dispersal is 360. Propagation 360. This one is just unidirectional. Obviously, any seeds going backwards will not propagate. So it propagates only in one direction. And there's nothing much to learn in here other than the fact that these arrows create new vegetation. So your seeds are going to, of course, create new plants. For the exam, it's nice to remember that in the prairie ecology, they expect a regreening. the reading question for the exam, what are the sources? One is the seeds. Let's make it general called propagules. And then the roots of the perennials. The roots of the perennials. You see how specific we get? Sundry perennials, part of our common language. Good. In the gardens, not in forest so much. We do. All right. So 2 sources, and that creates different patterns depending on what's left intact. So what you're looking at in beef, just to mention, are patches of unburned. Patches of unburned. Again, control fire is controlled, therefore they know the intensity. Intensity is, I don't have the scales, but I figure from 1 to 5, for example, so they sure have control. They have to decide whether they leave intact vegetation or not. That will lead to different, write this down, I'm gonna say succession, term that I haven't seen that book. You know what succession is? So recolonization and succession of species, rebuilding of the community and so on. And these 2, so the different patterns of burning will create different succession patterns. In other words, what you're likely to see for fuel in 5 years, correct? So to them, that makes a big difference. So long enough for me. I'm going to stop right here for your attention, and we'll see you next time.
You have any?